Yeah. Okay, so the talk is going to be fairly short because I'm not talking about anything new. Whatever I'm going to talk about is already a solved problem, but I'm just going to talk about a way that I discovered, um, which is sort of a more intuitive way to solve the same problem. So, the problem is managing side effects with observables. We've already heard a lot about observables in our first talk, I think. So this just continues from there, I guess. So what are side effects? Side effect is any interaction that your application has with the outside world. Anything that is outside the scope of your current application is basically a side effect. So those could be things like being HTTP requests, writing something to local storage, or manipulating a DOM. So if you think about it, the last side effect that is manipulating the DOM has been solved by React. So that basically takes care of this side effect for us. It manipulates the DOM for us. And we treat that as a black box. We don't actually do anything that says, okay, go and append this child in this step, or remove this child in this step. We just mutate our application state, and then React decides how the DOM needs to be mutated based on that change. So React takes care of manipulating the DOM for us, but there are side effects in our application that we still need to handle, such as these ones, maybe HTTP requests, right, global storage, or something else. I mean, there could be a lot of things. So why are side effects bad? Ideally, if you were writing an application and it was a pure application and it didn't do any side effects, then that application would be useless. To bring out some utility from our application, we have to do some sort of side effect or the other. But the problem here is side effects are unpredictable. You cannot always be sure how they'll behave. You cannot always be sure that an API request is going to return in 1.2 seconds or 1.3 seconds, or it's always going to return this HTTP status code or that HTTP status code. Yes, the server might be down, something might be up. So side effects are unpredictable, and because of that, they're hard to maintain, they're hard to test, because again, they're not in the scope of the application. So how will you devise a test strategy that goes ahead and actually tests if your side effects are being handled properly? So therefore, as developers, our job is mainly to manage this complexity and minimize or localize our side effects to certain parts of our application where we can see them all in one place. And maybe if we do it that way, then we can deal with them gracefully. But that's still a mean. So there are a lot of popular already existing solutions for this problem. These are, if you guys have used Redux, is anyone using Redux yet besides the house utility? Okay, so cool. So you guys know what a middleware is, Redux middleware. So there are a bunch of middleware that you can already use. More popular ones are Redux Thunk and Redux Saga. So, so basically, what these do is they let you describe your side effects inside of your action creators only. So a thunk will provide you a thunk-based action where you can describe your side effect, and the action will be called by the middleware for you. But there is a slight problem with this. This is good as long as the action that you're creating inside of your side effect is not dependent on the current state of your application. For instance, if you are dispatching a thunk that depends on the current state of an application, then that state becomes an action creator in itself. So that if, when you look into your Redux history, like your action history, then the action dispatched by that thunk would have been dependent on the previous state up to that point in the application timeline. So if there was any bug in between these actions, it would be hard to trace where that bug came from because you already put that action inside an action creator. So for you, that is a sort of outside event, and since that action was dependent on your initial state only, like your existing state, so you won't be able to exactly pinpoint where that bug originated from. Redux Saga also does the same thing. It's sort of a one-to-one mapping of Redux things when it comes to the actual middleware. And there has been a lot of discourse on this on Twitter, on GitHub issues, on just by folks like Indy and even Dan Abramo, where the problem they think is that Redux thing is too powerful. as a and this should do everything. So I'm going to talk about something called Redux Observable. Again, we don't really need to use a library to use the things that we're talking about. What this library basically does for us is it basically subscribes to the observables inside our React component lifecycle methods. So it will subscribe to it, subscribe to it, and all. And we don't need to do all of that as well. This library basically does it for us. And this was basically written by folks over at Netflix, and they use it in all of their apps basically. So Netflix has a purely JS-based architecture on televisions that are in JavaScript. So they basically use this framework for their state management. So what Redux Observable basically is, it uses reactive programming to compose case metrics that dispatch actions to our Redux reducers. So we talked about reactive. I think the first speaker talked about a lot about reactive programming. So again, reactive programming in a line, I think, would be a program that interacts with the outside world, but it does not control how that interaction would take place. The outside world will interact with our program, but we don't control how that interaction is going to take place and when that interaction is going to take place. All the interaction is basically put to our program. We don't decide when it's going to come. We just wait there and wait. Whenever it comes in, we just react to it. So that's reactive programming, and we're going to make use of that. And how we are going to use it is through something called an epic function. So if you use Redux sagas, then you write a saga basically. If you use Redux observable, what you're going to write is an epic. So what an epic is, it is a basically simple function, and it gets the stream of all actions that are dispatched in your application. Whenever you dispatch an action anywhere in your app, any epic that's registered by your Redux store will get all of the actions that are dispatched as a stream. And what that function needs to return is another stream of actions that you think should be dispatched based on the actions that you just received. So the signature, function signature looks sort of like this. So we get two arguments. The first one is an action dollar. So basically, whenever you see a dollar, that means it's a stream. So it's not an array or a discrete thing. It's a stream of actions. And the stream is structured in a way that every item in the stream is an observable, and that observable encapsulates an action. So basically, an observable of an action means like you have an action that is a plain JavaScript object, a Pujo, and it's been wrapped by an observable, and we have subscribed to a stream of these observables. The second argument which we get is a store, and this is your normal Redux store. Actually, it's not the usual Redux store, it's a mock version of the Redux store, and basically it exposes two methods, get, state, and dispatch. So that's your normal store. And what we need to return is another stream of actions, uh, which are the same type as the stream that you got in. So if you've ever seen a Redux middleware, I'll show you one. Yeah. Can you see this part? Can you see that code? Can you see this line? Yeah. So that's the signature of a Redux middleware. So it takes a object, it returns a function, which takes in another argument, which returns a function finally. So that's the signature of a Redux middleware. Now, if you're a library author and you're writing Redux middleware, you have two choices. Either you can listen on actions after they've been through the reducer, or you can listen on actions before they even go to the reducer. So, uh, Redux Observable as a library made the choice to listen on actions after they've been through your reducer. So the store that you get here, if you call the get state method on that, the state that you're going to see is the state that was inside of the store after your action has been dispatched and it's been through your reducer. So let's say if this is like a most simple example of an epic. So what is happening here is I'm getting the stream of all actions that have been dispatched in my app in action dollar. and then I'm filtering on them based on the of type operator. So what of type is basically doing is it's filtering all actions of type ping, and then what it's doing is it's mapping all of those actions to the type form. So what happens here is whenever I get an action, whenever I dispatch an action ping, like a usual dispatch call in your React application, it will go to the reducer. The ping reducer will be called whatever reducer you have defined against the ping type action that will be called. The new state would be returned. It will be put inside your store, and then the control will come here. The program control will come inside this epic. It will say, I just received a ping action. The state has been updated in the store. Now what you can do is you can map that action to a type form. So whenever it receives an action of type ping, it goes to the reducer, gets a new state, then dispatches another action after it's been to the reducer of type form. Cool, but this is like a very primitive example, nothing fancy here. So basically, the advantage of using and setting up all of this was now we have the power of RxJS, all of reactive programming operators, transforms, maps, everything. Those are available to us now. So if for some reason I wanted to delay the dispatch of form asynchronously by 1 second, I just have to write delay 1000. Delay is an RxJS operator. So if you guys have seen RxJS before, you know there are RxJS operators which can work on your action streams. So what is happening basically here is it's the same as the last one. But what it will do is after the ping reducer has been called, it will wait for 1 second. And this is an asynchronous wait. So your other parts of your application are still working. It's not blocking anything. It's just waiting asynchronously for 1 second in the background and then dispatching the phone action. If you want to see this live, there's a JS bin setup. So if you are following on after, we can see that. Cool, but these are very primitive examples again. Now I'll show you something that we actually use. So as Vivek said, we're using a CLF form in our product, and basically what happens on the submit of that CLF form is we dispatch a post to our backend, and there's a bunch of stuff that we need to do around that post call. So there it is right now. So let's say on the click of that submit button, I dispatch an action of type CLF submit. And that action is again a normal action. In that payload, I have some information related to what the user filled in that form, and yeah, all of that stuff. So what I do when I get that action is I call the merge map operator on that action. So what merge map does is basically merge map takes in a stream of observables, um, higher order observables. So an observable that returns another observable is called a higher order observable. So Mozilla basically takes a stream of higher order observables and flattens it out to a stream of normal observables. So it goes one step down. If you've done FP before, you've heard of this operator called fold or flat map. So it's basically the same thing. Merge map was called flat map prior to RxJS 5, but for semantic reasons, they changed it to merge map because it makes more sense. Cool. So what merge map here is doing here is it's flattening out my higher order observable, and where that higher order observable comes from is this Ajax call here. So again, this Ajax is like imported from RxJS itself, and what this Ajax call is doing here is it's creating an observable that just describes my XHR call. It's not actually making the XHR call here right now. It just describes that, okay, this sort of XHR call needs to be made. Now that observable will make that call sometime in the future, maybe whenever it gets time. I don't know, it will make it sometime. And when that response comes back, it will dispatch another action with that response of type CLF success. This is again async. We don't know when the response will come. It might take 1 second, 2 seconds, 3 seconds, or it might even fail. We don't know yet. And then after it dispatches the action of type CLF success, it will dispatch another action of type hide loader. So what we did here was we started this entire Ajax transaction with an action dispatch of type show loader. Because on CLF submit, we maybe want to show a loading indicator to the user. And we don't want to handle this part on the UI. We don't want to say, okay, on click, render my loader. We don't want to do that straight away. So we just handle that inside a Redux state only because it's convenient. So I start this entire transaction using this cart with operator here with a type show loader. So before even that Ajax call was then the Ajax call was made, I received a response. I dispatched two actions. So one was CLF success, the other one was hide loader because my transaction is complete. Now the most interesting thing in this epic right here is the last operator, take until. So if you guys have used promises before, I think most of you must be using promises. Promises is again another way to solve the problem that we're talking about. But one problem with promises I feel is they represent an immutable value. So a promise when it's created will represent a value that cannot be changed. It will be at one of two or three states, pending, resolved, or failed. So what happens in the case when you want to cancel a promise? How will you do that? If you made a network call and you instantiated a new promise and you said when the response comes back, resolve it with whatever the response was or reject it if my network call failed. That's only two states. But if for some reason in the middle of the network call I want to say I want to cancel this request, then what do I do? You won't necessarily do that, by the way. You have to work around it, correct? Yeah, you have to work around it. No, you cannot do that by promise.trace. Still, your resolve handler would handle whatever comes back. I don't want my resolve handler to handle whatever the response was because maybe I'm working on a slow phone and I don't want to waste any cycles on pending network calls that I didn't need anymore. So an example could be if you were, let's say, browsing for one property, you clicked on the property and I started loading the data for the property, but for some reason you decided to click back. You change your mind, you don't want to see that property anymore. But in the background, I made the network call and the data for that property is already coming. And I have a handler waiting that's waiting for that data and will do some calculation on that data, maybe update my store with it. Maybe my React view will re-render again since my store has been updated. But I didn't want all of that because the user already pressed back. So how do I do that? So RSPX basically solves that problem for us. So since we are dealing with streams here, the most straightforward way here is to unsubscribe to that stream. We don't want it anymore. So I can just dispatch an action whenever I feel I don't want to. I want to cancel my request. I just dispatch an action of type CLF underscore somewhere underscore cancel, and my entire epic has been set up in such a way that it's only going to listen for actions as long as it does not get an action of type CRF underscore somewhere underscore cancel. As soon as it sees an action of type CRF underscore somewhere underscore cancel, it's going to unsubscribe for that particular cycle of execution and basically ignore everything that happens after that. So I don't waste any CPU cycles passing the unrequired data that I had. Uh, yeah, and that's usually a problem when you're dealing with very low-end devices, probably sub 1 gigahertz processors. This really makes a difference if you have a big application. Cool. Okay. No, how can you? It's just going to be neglected. It's not going to waste any CPU cycles passing what you call. Because see, what you're trying to describe is impossible. Once I dispatch the network request, I cannot go and cancel it in any way. It's already gone from my control now. It's on the network, it's on the wire. So I cannot cancel it. So yeah, I cannot do. No one can do that basically, but we can actually ignore the response that comes back from it. Cool. So that was one use case. Another use case is, I think in the first talk only someone described that they're using the bounce. So the bounce is basically a very common thing that you need to use in a production grade app because you don't want something to be called over and over again. And the most common example of that is an auto suggester and autocomplete info, where you type in something and then you need to show an autocomplete suggestion list at the bottom, which gets populated immediately as you type some stuff. But the problem here is if you dispatch an input call and get new data every time there is a change in that input box, you have to make too many network calls. If I bring in new data on every word, keyboard character press, then that's going to make my application really slow. I need to debounce that somehow. So again, that's really straightforward with RxJS because I have all the operators at my disposal now. I basically use a bounce time operator. So what this is doing there is it's listening to all dispatches of type locality autocomplete. So whenever my text input changes, I dispatch an action of type locality autocomplete. And this epic debounces this frame for 250 milliseconds. So it will take in an action of locality autocomplete, and then uh, if for the next 250 milliseconds another locality autocomplete comes, it's going to ignore that. And then it will take another locality autocomplete action once those 250 seconds are over, and it's going to repeat that over and over again. Cool, so that's the bounce. Another operator we used there was distinct until change. So I don't want to fetch new results if the previous input was the same as the new one. So I'm sure the results are going to be the same because the input hasn't changed. So I don't even dispatch that. Cool. And then after debouncing and making sure everything is not the same as before, again I use the switch map operator. Switch map is again another higher order observable to a flat observable stream uh, strategy. So there are a bunch of these. There's one called concat map. There's one called merge map, which you've already seen. This one's called switch map. What's this? What this is going to do is the same thing as last time. It's going to make an XHR request. Now, we're doing a couple of new things here. We're also retrying that request 3 times. So maybe my XHR request failed the first time because of some reason. I was out of network or the server was down. I got a 500. And I need to retry the request. Usually, the place where you write this is in your networking library. So if you're using something like Axios or Fetch, maybe, then you'll write a global handler sort of interceptor where you put all of this logic. But again, then you can't do it on a per request basis. Maybe I want to retry this request only twice for some reason, or maybe I want to check what the input was and then decide how many times I want to retry that. So I can again do all of that stuff here. I can retry it as many times as I want. I can check the payload of my initial action and then decide, okay, this was a very big search query, maybe I should retry it 4 times. Cool, I can do all of that declaratively, it's all here. And again, if that network call succeeds, again, I map whatever response I get to an action of type locality suggests success, and I pass in the data that I get from my server as a payload there. Also, I'm using the catch operator here. So if my network call failed and then I retry it thrice, it failed thrice then I can dispatch another action, which would be via this catch block that I'm using, and that's going to handle my error state. So if I can show you how this is working.
What's going on?
Yeah. So we've been using observables in our React Native app. We haven't used it on the web or mobile yet. But as a pilot, we think it's good to prototype on React Native and then figure out how it's going to work. It's been working pretty good so far. So yeah. So this is that auto suggest thing that I was talking about. I need to make sure. Yeah. And yeah, the code is. So yeah, there's the code that's handling that auto select box. If you go do this by some other sort of architecture, if you use maybe promises, or if you maybe use sagas, or even if you use Redux thumb to solve this problem, you will find that you'll have to write this code in a bunch of places. You cannot all like put all of this code inside one file. It's really hard to do that because I tried it. I could not fit all the code that I need to make and auto suggest they bounce the input box inside one file. For a React Redux-based architecture, it's really hard to do that because there are a lot of places and a lot of parts of your application this piece of code is interacting with. But RxJS really solves that problem for you. It's like three lines of code and you have an autocomplete working out of the box. Cool. And also, if you want to see an example of the loader, so yeah. So whenever I click on that button, I say, okay, I want to load new data, it automatically dispatches a call to show the loader. And when I get the data back, it dispatches another call to hide the loader. So all of that data is also, all of that information is now serialized. I will get an action in my Redux logs where it will show me that you dispatched an action of type show loader so that you can realize, okay, the loader was triggered or not. You don't need actual UI to debug that now. Cool. Uh, so we saw we can use RxJS operators. That's very cool. You have all of these off-type, DevOps-type operators. That's all very fancy. You have this Ajax thing, which can return observables. That's also very fancy. So if you can do all of this stuff and it's so powerful, why do you need Redux at all? So this is a quote from the Redux official docs itself. That's a link where it is. And what it says is the question is, do you really need Redux if you already use RX? Maybe not. It's not hard to re-implement Redux in RX. Some say it's the two-liner using RX.scan operator method. It may very well be. So if you're familiar with RX, then there is this thing called scan. And scan is basically an accumulator function. So you have a reduce function on your arrays, normal arrays, wherein you get a first argument that's an accumulator, and that has all the previous responses of that operation that you pass in as a third function. So scan is very similar. What it is basically is analogous to a reducer. So it takes in your old state, returns a new state, and merges that new state with the current state of the application. And it's a one-liner, so you just give it a function that accepts in previous state, and the second argument is a new state, and then you just deep merge that new state into the previous state, and that's Redux for you in a line of code. So why do we need Redux then? The answer is basically the same as what is the answer to a lot of tools that we use today. The community is really good. There are a lot of tools built on top of Redux dev tools, a lot of useful middleware that are already there, which help you debug your application, figure out what's going wrong where. So Redux, and most of the people who are using React are already familiar with Redux. So if you integrate this sort of library to your existing Redux architecture, then you sort of get the best of both worlds. You get your existing Redux architecture and tooling, and then on top of that, you get the power of RxJS and reactive programming and composition. This is it. Uh, there is one more thing that I want to add, which I just sort of like thought of while listening to the first talk. So if we talk about this thing called functional reactive programming, uh, I'm not sure if most of you have heard of it, but there is this thing called functional reactive programming. So React introduced this concept of functional programming, where we say our UI is a function of our state. We just give it our state, it renders out some representation of our UI, and that's true for all state that's there in the application. There's something called reactive programming, which I just described. You use streams and compose streams and use operators and combine streams together and generate new streams. When you use both of those together, you get something called functional reactive programming. And there has been a lot of research into building user interfaces with functional reactive programming, because it turns out that this method of programming, this paradigm of programming is very well suited to coding UIs. And people have gone to certain extents to get it working. So there's this guy called Andre Stolz, if you've heard of his name. He built this framework called CycleJS, which is basically modeling the entire human-computer interaction as a stream of actions. So every mouse click, every scroll event, every page opening, every page closing, every click of a button is an action that is coming from the outside world in a continuous stream. And my application is just reacting to those stream of actions by transforming them again using all these things that we just saw. and transforming them to stuff that we think would be relevant to handle that. So yeah, that is taking this to the level where it actually should be. But we cannot do all of that stuff in our React or Redux-based architecture because we are bound by the platform that we're using. But if we take it to the next level, that's what it is. So as a corollary, you should probably check it out also.
Netflix.
Yeah, it's a file stream. So this framework, the library that I'm talking about, was co-written by two people. One was Ben Lesh, and the other one I forgot the name, but you could probably check out. I can read it. Cool, that's it.
Are we done?
Yeah.
Any questions? Anybody going to use this? Huh? Okay, going once, twice. Thanks a lot. Okay, so we got lunch.